How you doing? Sure, got everybody's photo here. Logan, how you doing? Good. All right. No questions. We're going to continue on today. I'll give you guys a few more minutes before there's specific arrivals here. Today we're going to continue on session 5, which is aerodynamics. Everybody is understanding this all right, huh? The terms and everything. So I think a big thing with a lot of this stuff is just remembering all the different terms that are used, in the system. So, or when you get into aviation, different things that'll help you understand questions on the exam itself. So if there's something you don't understand, definitely make sure you ask.
I'm called Zoom. It's used in Greenwich.
Greenwich, yes, yeah. So how you doing, Donnie? So yeah, that's a good question. I don't know the reason behind they call it Zulu, but it's always been called Zulu time. Yeah, so there's this time. It's called Universal Time Coordinator (UTC) time, which all pilots use. When you drive a car someplace. So if we're to drive from here to Minneapolis, for instance, you don't really have to worry about changing time zones. It's like you only go so fast. Back in the 1800s, when they had all these trains crisscrossing the U.S., they had to figure out a better way of saying, times are going to arrive at a certain time or whatever. They needed a better method for doing this. So they used UTC time or Zulu time or Greenwich time. Greenwich time is in Greenwich, England, in the UK, right? So that's where the prime meridian runs through, and you can actually go there and stand on both sides of the world's hemispheres there. So the east and west hemisphere. It's really cool, actually. There's just a gold line in the ground there, and that's actually the National Observatory there. But in any case, at that point, it's that's Greenwich time. So whatever the time is there, that's what pilots use. So we don't say I'm going to leave here at in Baraboo, let's say, and I'm going to go out west. I'm going to leave at 11 o'clock a.m. here, but I get there at what time? It's like, do I say that I arrive at their time, or do I say that I arrive at Midwest time? You know what I'm saying? So when you're flying, especially on airliners like your dad, they use UTC time because the airliners are moving so fast that ATC doesn't have time to figure out, okay, well, this guy's now flying in this zone, this time zone here, let's say like the Pacific time zone. They just use universal coordinated time, and that way it's the same everywhere on the planet. So, if it's 0 Zulu here in Baraboo, it's 0 Zulu everywhere on the planet. Okay, that's the difference. So right now, our local time is 9 o'clock, Central time. But if we were to go to New York from here instantly, their time would be 8 o'clock. Oh, 10 o'clock. Thank you. Yes, I get this mixed up. So that's with universal time, the Zulu time, it's always the same. So, and if you're flying an SR-71, for instance, across, just think how many time zones you pass through as you're crossing the U.S. or going through the planet. You'd be crossing quite through a few time zones, and you don't want to have to worry about telling ATC, I estimate my time to be at such and such a time local. It's too much math. So they just said, It's just everything in aviation is just UTC time. And it's really easy to figure out. So, essentially right now we're 6 hours, behind UTC time. So if it's 12 o'clock in Greenwich at UTC time, it's going to be 6 here. It's essentially how that works. So, and of course, we've got daylight savings time, which kind of messes things up too. So it's those are all things that you have to consider. So, but it's all, UTC time is UTC time. It's if it's 12 UTC in London, it's 12 UTC here, and we do it in military hours in aviation too. We don't say it's 11 a.m. UTC. We just say 1100 Zulu time. And that's normally the way you say it. So if you were to have a conversation with ATC and you estimate your arrival time to be at, let's say, 9:45 Zulu, 9:45 a.m., let's say, or I should say just say 9:45. I would tell Madison, it's a Madison estimated time of arrival. It's 9:45 Zulu time on there. So which would be essentially 3:45, right? Because you have to track the time. Or let's see. Yes, yeah. So Zulu, because again, we're going from Zulu back to local time. And again, it's going to be different. And we'll actually talk about this more later on. So don't worry about trying to remember this stuff. We get into what that's called. We get into that in the cross-country navigation stuff. So, but yeah, to answer your question, though, I honestly don't know why the term Zulu was used, but that's what's stuck, and so we always say Zulu time. So Greenwich time or universal time coordinated time. So all right, let's get started. All right, so I think last week we left off at stabilities, right? Dynamic stability, we talked about static stability. I think actually if you turn to page 518, 5-18. That's kind of where we left off. And we'll just start right at the top of the page on second and 5, page 18 there. All right, so the first item they have there is a dihedral of a plane. Talks a little bit about the shape of the wing. So dihedral on a plane is the bending up of the wings a little bit. And the reason they bend wings up a little bit like that when they design a plane, you can see it in this Piper right here. This is a regular Cherokee right here. So if you look at that, there's a slight, the wings kind of bend up. Can you see that here in this one right here? It's the dihedral is that sweep up of the wings like this. It's like that. What that does for the plane is it gives it a little bit more stability. And when we're talking aerodynamics, as a general aviation manufacturer, if we were to design a plane, we could design a super fast plane, but it would be incredibly dangerous for the average person like me to fly. So what manufacturers do is they build in all these features to make sure that the plane is easy enough for the average pilot to fly. So this is dihedral. It's that bend in the wings like this. Most high wings don't have it because they're already fairly stable this way. Low wing aircraft, you will see some dihedral. It's very slight in this. If you look at this one, there's a slight sweep up in the wings there. You see that? And again, what that does is what dihedral does is if you happen to hit a gust or something like that, the plane is going to try to correct itself. If it goes up like this, this one's going to have a lower angle of attack at that point, and it's going to kind of correct itself like that. So that helps with stability of an airplane. And when we get into aerodynamics, we talk a lot about stability. And general aviation manufacturers, again, they want to make planes that are fairly safe, to fly. The first time I flew a plane, I thought if I let go of the controls, the plane was just going to spin out of control and it was going to, do something crazy. It doesn't happen at all. You can literally fly an entire, I've done this before, other than takeoff and landing, I've done it. I've flown an entire flight with just rudder pedals and trim. You don't even have to touch the yoke, especially on a really calm day. It's really easy to do. Even in bumpy, turbulent conditions, you can still, control the aircraft with just the use of the rudders. Get it to bank. You can get it to pitch up and down with trim and things like that. So the less you touch the controls in flight, probably the better you're going to be, because oftentimes pilots will put in inputs there that they don't really need to, and it winds up making more work for them. So sweep back, it's a term you won't see on the test, but I'll talk about it anyway. Sweep back has to do with switch over to vortices there. Okay. Yeah, this is an example of sweep back. See how these wings are swept back. You typically see this on really fast aircraft, and the reason they do that is because it has to do with if the faster an airplane gets to the speed of sound, the less stable it becomes. Like if I were to take this, let's use this one right here. So this is a Japanese Zero, as a matter of fact. So it's if this plane were going through the air at close to the speed of sound, the sound wave that is hitting it, if you're actually able to see it, would actually be touching the leading edges of these wings right here, and it disrupts the flow. I mean, it'll actually, the plane will lose control. And they found this out originally. The Americans found it out with the P-38 Lightning, which is a big twin engine. I shouldn't say big. It was a larger fighter bomber that was used in World War II, and it was a very fast aircraft. It really booked, and so much so that when they got close to the speed of sound, they had problems with it. And most fighters by then still weren't able to get quite close to the speed of sound, but P-38 was. And in a dive, it could actually reach the speed of sound. But what happened was, because of that disruption of the speed of sound, those waves that were hitting the edges of the wings there, it prevented the pilot from pulling out of a dive, or they actually couldn't even use the elevator on the plane. It was going so fast. And that's, again, because of the disruption of air. Air acts very differently when you get close to the speed of sound. And again, you don't have to worry about this because we're general aviation pilots later on. If you go to the military, you're going to have to know it. And that's where you get into if you want to learn more about the aerodynamics of the sonic flight or speed of sound, the Aerodynamics for Naval Aviators is a really good reference. It's an old book, but it's got lots of really useful material in it. So anyway, that's sweep back. Keel effect and weight distribution. So we all know what a weather vane does, right? You've seen weather vanes before. If I were to take this and put it on a post and stick it outside, if the wind was blowing from this direction, which way would this plane turn? It would turn into the wind. That's a weather vaning effect or keel effect. So, and that's natural. Again, this is good for us as pilots because once we get the plane moving, the plane just naturally wants to go into that direction where the wind is coming from. In this case, our relative wind is going to be this way. So the plane wants to stay in that direction because of this keel. It's just like a keel on a ship. It just keeps it steady. You got that vertical stabilizer right there. That's just holding it steady. That way, if we hit a bump and the plane yaws to one direction or another, if the wind is, if we're flying in this direction and it bumps like this, it's going to want to straighten out again. So that's another stability enhancement for an aircraft. Again, they can build into planes, and every plane that has a vertical tail surface is going to have that built into it. Some aircraft have smaller tail surfaces, so they're not going to respond the same way as other aircraft. Aircraft manufacturers understand that. That's why they could make a super huge vertical stabilizer so that you wouldn't feel much yawing at all in the aircraft. You know, if you hit a bump, it would stay pretty steady. The problem is the larger, more surface area you have on the plane, more structures you have on it, the slower it's going to go. So they've got to balance that with the size of all these components with what their function is. So they usually come up with a good balance where they can maintain a decent speed. Instead of a plane going at maybe 60 knots, they now can get it up to 120 knots and not worry about losing any stability with it. So let's talk about the different types of stability in the plane. This is getting on. Well, actually, there's one term they have here: directional stability. Yawing. So we know what yaw is, right? Everybody know what yaw is? Okay. So to yaw in aircrafts, if I press on the left rudder pedal, plane's gonna yaw in that direction. It's not gonna turn in that direction. It's just going to yaw in that direction. Okay. If I want to turn in that direction, what do I have to do? Anybody? Roll. And what else? Pitch. Yep. Roll and pitch. Because rolling into it, if I want to turn over here, if let's say I want to go to that corner of the room, it's not enough just to turn the ailerons into the turn itself. I have to pull back on that control yoke because we need to generate lift in that direction. We need something to push us in that direction. That's the lift there, okay? So that's what we're actually converting our vertical lift when we go into a turn. We're going to talk about this later today too. So basically, we're turning that sideways motion. We're actually going to pull back on the control yoke, which is going to cause the turn in that direction. That's what gets the plane to turn. It's not the rudder pedal. So if anybody asks you what causes a plane to turn, it is not rudder. Never say rudder. Always say it's pitch. Into the turn. You're actually pitching or angle of attack, if you want to say that too. You're using that to turn into a turn. Okay. So again, yaw is like this. It's just back and forth. This is yaw right here. So if I step on my left rudder pedal, let's do it like this. If I step on my left rudder pedal, it's going to yaw this way. If I step on my right rudder pedal, it's going to yaw that way. It's not necessarily going to turn. The direction of the position of the nose is going to change, obviously. So if I'm at 360 degrees here and I press my right rudder here, it's going to yaw maybe to like 20 degrees, the heading of 20 degrees as opposed to 0, which is, or 360, which is north. I think that's something we'll get into later on. So, but again, that's the heading of the aircraft. So directional stability, it's pretty, directional stability again is built in by that keel effect we were just talking about. That vertical stabilizer helps keep it, from yawing all over the place. If you have some aircrafts do have smaller rudders for speed reasons, they want to get more performance out of it. And because they have smaller rudder, they actually have special equipment on board to help keep that yawing at a minimum. So they have what's called a yaw damper. You don't have to know this for the test, but like a lot of jets, they'll actually have what's called a yaw damper that prevents the plane from doing this during the flight. If you're dealing with a really fast, high performance aircraft, they oftentimes will wander a little bit. They'll wag their tail as they're flying along. What a yaw damper does is it takes that yaw out of it so it flies nice and smooth. And again, most of the smaller airplanes that we fly as trainers are going to have that built in effect. You won't have to worry about the plane yawing like this as you fly along there. So, okay, let's see. I could talk about Dutch roll. This is on page 5-20. They call them free direct oscillations or Dutch rolls. It's not something you're going to see. It's a situation that can happen in a plane when it gets into a certain type of oscillation. You generally don't see it in most training aircraft, but I'll explain how it works. Essentially, what a Dutch roll is, and you could induce a Dutch roll in a plane too. Essentially, what it is you're basically you're going to apply some rudder. When you apply rudder to an airplane, what's going to happen is if I apply left rudder on this plane right here, the airplane's going to go into a This wing right here is going to produce a little more lift because it's moving through the air faster. We know that as a wing moves faster through the air, it produces more lift, right? So it's going to produce a little bit more lift, and it's going to cause it to go that way. And then to correct it, we apply right rudder, which causes this wing to come up because it's moving faster. And so we get into this oscillation. Some planes are unstable, and once they get into a Dutch roll, they may not be able to get out of it, and it gets so bad that the plane will eventually would crash. They've got, I think it was one of the Lear jets that has a problem with Dutch roll. Somebody would know more about that than I do, but I know that it is a potential problem in some higher performance planes, not so much in trainers. But you can do a Dutch roll. I've done it before. There's nothing scary about them. You just apply rudder, and what you can do when you apply left rudder, for instance, if I apply left rudder right here, let's see, the plane is going to turn like this, and because this wing is going faster, again, it lifts it up, and then we apply left rudder, and then this wing is going to rise up like that, and it's just going to go into this oscillation like that. You're just going to apply rudder back and forth, and the plane is just going to oscillate. Right. So if I apply left rudder on this side, it's going to cause it to go this way. If I apply right rudder, sorry about that. Yeah, thanks for catching that. Yeah. Okay, so yeah, so if I apply right rudder here, it's this. Then this left wing here is going to travel through the air faster, right? And it's going to raise it up like that. And that's again your Dutch roll tendency. And again, some planes will just do this on their own, but again, it's going to be more the higher performance planes. So let's see here. Wing plan forms or plane forms there. So let's go there. Here we go. So these are the different types of wing designs that you're going to see in aviation. They all have various purposes. Some are much safer than others, and others are designed for performance, higher performance. The two that you're going to see the most often are going to be in general aviation, like a Piper or a Cessna, are going to be this rectangular one right here, and this moderate taper wing. You're going to see those quite a bit, and you'll see combinations of those. The rest of these are going to be more toward higher performance aircraft. The elliptical wing. Does anybody know, just out of curiosity, a famous plane that used the elliptical ones? What's that? P-47. Yep. The other one, the big one was the Spitfire. It had a very pronounced elliptical wing. And if you just next time you see a British Spitfire, you won't see. I think there's only like one or two of them flying in the world now. But if you ever see a picture of one, just take a look at the wing shape of it. And it was a very high performance aircraft, obviously. But yeah, most of the fighters you're going to see are going to be most of the planes you're going to see in general aviation are going to be either the rectangular or the moderate taper wing. Generally, you're not going to see sweep back for general aviation planes. Now you will see them for commercial jets, like private jets. Oftentimes they'll have sweep back. Sometimes they don't. But some of the faster jets, we know all the commercial stuff, like the airlines, they all have swept back wings because they travel so fast. So, and again, that's because they're going so fast and they have to worry about that's for efficiency purposes, and also they have to worry about getting up to close to the speed of sound. They're very close. They get very close to compared to a training aircraft, which maybe only goes 100, 150 miles an hour or something like that. Okay. All right. So let's go on and get into see that here. And just go ahead here. Did I skip an area about stabilities? Oh yeah, okay. I'm sorry. Turn back to page 5-14. We just need to go over. Excuse me. the different types of stabilities. These you do want to know. So there's two different types of stabilities. There's what's called static stability. That's on page 5-14. And essentially what static stability is, it's when if you disturb something, it's what that object is going to do after you disturb it. So the simplest way to describe static stability would be to grab a marble and a bowl and to put the marble in the bowl and then move that marble up the side of the bowl and let go of it. It's going to always try to get back to that center portion of the bowl. In a plane, static stability is as simple as this. So what you would do here is, you would, let's say, pull back on the control yoke. Static stability there's one of three things that can happen. The plane is either going to stay in that position when you pull up the yoke. When you let go of it, it's just going to stay like this. That's neutral static stability. Or it's going to try to get back to where it was, which is back down here. It's actually going to point down. So that's static stability. Negative static stability is you pull back on the control yoke, let go of it, and it continues on like that. And that's pitch stability here. In this case, we're talking about pull back on the control yoke. If I let go of it and it just stays at that attitude there, that's neutral static stability. Okay. So static stability describes what happens to an object once we apply a force to it. That's static stability. And again, the three possibilities is that it's going to be positive, which means if I pull back on the control yoke, it's going to try to get back to where it was on there. That's positive static. Negative static, if I pull back on it, it's just going to keep rising like that. That's negative static. And neutral static stability is pull back on it, it just stays there. Okay. So again, static stability is when you first apply that force on the aircraft. What does it do? Does it want to continue on? Does it want to go back to where it was? Which is what we want to have with general aviation aircraft. We want the plane to go back to where it was, so it's somewhat stable. And then neutral, again, pull back on it, stays the same. We can say the same thing about roll. So roll has different static stabilities, right? So if I roll the aircraft to, in this case, to the left, like this here, if I let go of the control yoke, is it going to keep rolling? What would that be? Would that be positive or negative static stability? Negative static stability, exactly. If it rolls back up to, let's say I'm flying along this, I roll to the left, and it wants to go back, what is that demonstrating? Positive static stability, right? And then if I roll like this and it just stays there, neutral static stability, perfect, okay. So dynamic stability, this is where it gets a little confusing. Dynamic stability has to do with the time after you change or apply a force to it, okay? So static stability, again, pull back on the control yoke, it stays there, it's positive, it doesn't move at all. So dynamic has to do with what happens to positive and negative static stability over time. And what I mean by that is if you pull the control yoke back, and let's say this plane demonstrates positive pitch stability, okay? Pull the control yoke back, the plane goes up like this, well, it's got positive static stability, so it wants to go back down to get to where it was before. But dynamic stability is what happens after that. So let's say it pitches down, but maybe now it goes down through where we're at. Let's say we're rated here. I pitch up like this, the plane comes back and then goes down, but oftentimes what will happen in a plane is it'll go up and down and oscillate back and forth. So negative dynamic stability is those oscillations dampen out. That's negative dynamic stability. They're going to slowly, stop the oscillations, and it's going to, the plane's going to come to kind of an equilibrium. Whereas let's make sure. Oh, I'm sorry, I got that wrong. Positive dynamic stability is where it actually stops. It starts to dampen out over time. So if I pitch up like this, This is now the plane's going to come back down. This is demonstrating positive static stability. It wants to go back down, but now it goes through the point we were at in space before, and it starts coming back. And positive dynamic stability is it's going to stop those oscillations over time. So we can demonstrate that in the sim really easily. Let's see if I can get this up. Let's make it a little bit easier to see here. Get that column with that down. Okay. This is not going to be pretty, guys. See how it's turning there to the left? We're going to actually go over that in a second here. I just want to get that up to a reasonable altitude here. So okay, so let me go ahead and I'm just going to trim this down a little bit, slow it down a little bit. Let's actually turn the autopilot on here. Well, no, I don't want to do that. Just get it stable here. So I'm actually just trimming the aircraft out. We talked about trim, what it does there. Okay. Okay, so we've got it. We're flying along. Let's God, it's so hard to get these things done. Okay. All right. There we are right now. Okay, so we're flying along in a fairly stable motion here. So I'm going to pull back in the control yoke. Watch what happens to the plane. This is going to demonstrate positive static and positive dynamic stability. So we pull up like this. Okay, and see now what's going to happen here is the plane is, see how the nose is starting to pitch down? That's demonstrating the positive static stability. It's trying to get back to equilibrium. But what's going to happen over the next several minutes, we won't wait the whole time, is it's going to come back down. It's went through our altitude, and now it's starting to come back up. It's starting to do that dynamics, positive dynamic stability. It went past our original altitude. Now it's coming back up, and it's trying to get back to that equilibrium there. That's demonstrating positive static and positive dynamic stability. Does that make sense? Seeing that? And I can do the same now with roll. Generally, roll is going to show positive, well, it actually is neutral in most general aviation aircraft. What I mean by that is if you go into a roll like this and let go of the controls, the plane is just going to stay in that, location. It's not, it doesn't always come back to, in some general aviation aircraft, it will try to get back to, equilibrium, or basically a straight level. It depends on how much dihedral the plane has and other design characteristics of it. But a lot of high wings, once you bank the aircraft, it just stays there. It's going to stay in that bank. You just let go of the controls, and the plane will stay banked like that. It may have a tendency to turn steeper depending on how far you roll into it. If you do a steep roll, it's going to want to keep going over. It'll literally roll upside down if you don't correct it. So we actually go into a roll. We're going to take our control yoke, roll it, and then let go of it essentially, and it'll stay in this turn like this. We may actually have to hold some opposite aileron to get it to stay at that angle bank there. So with roll though, there's generally speaking, it's neutral static. If anything, it might be positive static stability. It may try to go back. Again, it depends on how much you roll to the left. If you only roll like 5 degrees, it's going to probably correct itself and go right back. So that would be positive static stability on that. But if over time, for like dynamic stability, for a roll, if you roll into it and you let go of it, it's just gonna demonstrate neutral dynamic stability. It's not gonna, there's not gonna be any oscillations back and forth. It's just gonna stay there, once you get it set there, unless you apply forces to it. Again, it depends on the, how much force you put into or how steep the bank is and things like that. It's going to affect it as well. So all these things, all this stuff, when it comes to stabilities, things like that, it's really about designing aircraft that are safe and fairly easy for the average person to fly. A lot of aerobatic aircraft, none of these things apply because they want an unstable. You can't have a super stable aircraft and make it an aerobatic plane. It just is impossible. If you want to do some of these crazy things, if you guys ever go to Oshkosh, they've got all day long, they have, aerobatic demonstrations and things like that. Some of those things cannot be done with a really stable aircraft because the airplane resists some of the inputs that the pilot puts into the plane if they want to, do some crazy things. I mean, I feel like these tail slides that some of the pilots do up there is just crazy what they do with it. But the planes, most general aviation airplanes, kind of have a hard time doing that. They just, they can't get it to do with it. I forget the term for it. It's almost like an inverted snap roll they do with it, and that's really difficult to do with a general aviation airplane. But basically, what you do is you flying around, you basically get the plane to fly like this and then apply opposite rudder, and the plane just does like it's like an inverted spin, horizontal spin. The plane actually spins like that. You can do the same thing. A regular snap roll is like pull back like this, kick in lots of rudder, and the plane literally spins like that in the air. And I'm sure you've seen those if you've ever watched aerobatic pilots do those. Those most planes can do. But again, as general aviation manufacturers go, they typically don't want to do that in a plane. They want to make sure that it's maneuverable, but yet controllable and somewhat safe for them. And that's why we talk about these different types of stabilities there. Okay, we're going to get into weight and balance here in a little while, so I'm not going to talk too much about center of gravity, but I do want to bring it up a little bit here. So with center of gravity, every plane has a point that that the center of gravity is at. It's in every plane. So like here in this aircraft, well, they don't show it there. So they've got the little center of gravity point right there. And this would be, if you were to think of this as a teeter-totter right here, you've got lots of weight on the front end right here and a little bit of weight in the back here. You get this long arm. We call it these distances from that center point. We call them arms there. Okay, it's just like a teeter-totter. Think of this as a teeter-totter. So we've got the engine up front, which is very heavy. So it's going to cause the plane to go down. We've got this long arm over here. It's causing the plane to go back, and so we can teeter-totter back and forth. That's what gives us our controllability of the aircraft. We can actually control it because of that. We can control the pitch. I can apply an elevator, and it'll pivot on that center of gravity. This is so fine. I think I maybe mentioned this in one of the other classes. I think I told you that I had a friend of mine that flew transcontinental or trans-Pacific flights in a 747. He could tell when a flight attendant walked from one portion of the aircraft to the other. That's how sensitive, and that's in a big aircraft. It's all 747. It's large, but he knew when a flight, just one person walked from one section to the other. That's how sensitive the center of gravity is in a plane. So on a small plane, same thing. A little bit of weight, added to the end of it is going to affect that center of gravity. It's going to move it forward or back there a little bit. But that's something, again, we're going to get into a lot when we get into weight and balance in the aircraft. So let's see here. All right. And let's go to through some of this stuff. There's some things we don't really need to cover. Does everybody know what the center of lift is? Okay, so we know what the center of gravity is. That's if we were to basically put a pin right here below the aircraft, we could actually balance it on the pin. That's the center of gravity. The center of lift is, it's actually this, it's literally the center of lift. So the whole aircraft is producing lift, right? I mean, the whole aircraft weighs something, right? So, but the center of gravity is right there. It's the same with lift. There's a specific point on the aircraft where that lift acts on the plane. And typically, it's just aft of the center of gravity on there. So if if you pitch down, to get it to pitch down, we need to produce some lift to get or we need to pivot it with the elevator itself, and that's going to apply more center of gravity here to the back of the plane. Yep.
So there's the center of lift change with the center of gravity.
Yes. Let me think about that a second here. So that's a good question. I believe it would. I believe it would. Gosh, I can't tell you for certain, but it's a good question. It certainly would. Yeah, when you think about it. So it depends on the weight distribution in the airplane. If the weight is further aft, the center of lift has to be center, further back on there. So I believe that's right. Let's talk about that later on. Remind me of that. I'll get to that. So, but typically in most aircraft, it's going to be just aft of the plane. The center of gravity does change when you load the aircraft differently. So if I drop off a friend, let's say we go for a flight, I drop them off and load 2 more passengers in the back of the aircraft. Toward this side of the aircraft, just like a teeter-totter, it's going to cause the plane to drop a little bit more like that. So we have to compensate with that by using elevator when we fly. We have to, we don't realize it, but in flight we're going to be applying more forward elevator, more forward trim to keep that plane flying. Whereas if I had like 2 passengers up front, just 2 passengers up front, that means that the front of the aircraft is going to have more weight in it, so it's going to want to pitch down like that. So that means I'm going to have to hold back more control pressure on the yoke. I'm going to have to pull that yoke back a little more when I fly, or trim the aircraft up so that the nose is a little bit higher. And again, you don't think about that when you're flying. You just know that the plane is not doing what you want it to do, so you just adjust the trim, and it's going to adjust that nose position there, the plane itself. So, okay. So center of gravity and center of lift. That center of lift is always, generally speaking, it's going to be aft of the center of gravity there. Okay. They talk about thrust and oscillations, which again I don't think you get into the exam. They don't really talk much about that. So let's see. We talked about lateral stability, directional stability. We talked about plane forms. Okay, so let's get into turns. And I think we kind of talked about this last week, but we didn't get into it a lot. So let's go back to our simulator here. All right, let's unpause it here. So we're flying along nice and straight and level here. I want to turn, let's say to, so I want to turn to the east. I'm going to do a left turn right here. But if I just bank the aircraft, right now, all I'm going to do is just bank the wings there. I haven't applied any rudder. I haven't pulled back on my control yoke. All we've done is bank the aircraft. Now it is you're going to see a slight change in the direction there, but it's not going to be a real dramatic turn. When we fly a planes, we want to get to our destination relatively fast, and it's the whole purpose of having an aircraft. So all I've done here is just rolled it. You'll see the directional gyro is showing a very shallow turn there, not much. What I want to do now is get it to actually turn in that direction. So now I'm starting to pitch back on the control yoke here. And you can see now that what's happening here. Let's pause here a second. So what's happening when I pull back in that control yoke, So there is, well, first off, we have our regular lift that's keeping the plane up. It's counteracting what? Weight. Yeah, it's, weight, gravity. We always say lift counteracts weight, though, to be precise there. So we've got that vertical. So if the plane weighs 1,000 pounds, let's say, we have to have 1,000 pounds of lift to maintain steady flight. But when we go into a turn, we've now converted some of that lift into a horizontal force called centrifugal force. That's actually, we want it to turn in that direction. So that means our vertical component of lift actually drops. Maybe we're at only 900 pounds of vertical lift and 100 pounds of horizontal lift pushing us into the direction of the turn. So that means what? What do we have to do if we want to maintain and we don't want to sink? What do we have to do as far as controls are concerned? Pull back on the control yoke. Yeah, or you pull back on it. That's going to do what? What's that? Generate more lift. Yeah, it'll get us back to 1,000 pounds. And now we have essentially our total load is at this point is 1,100 pounds on the aircraft, because you've got 100 pounds this way, right here, 100 pounds, and you've got 1,000 pounds. We want to stay in that turn. And this is starting to get in. Now we're starting to see the effects of G forces on the airplane. If I were to do a real fast, if I were to do a really steep turn and pull back and try to maintain my altitude, right now you can see down here, if I were to do a real steep turn, this right here is a standard rate turn. You can see there's our attitude indicator there. We're showing it 30-degree bank right there. But if I want to do a steep turn, which is 60 degrees, we're now going to have to apply even more back pressure, which is going to increase the amount of load that the aircraft is actually holding. So let's actually do that once so we can see what it looks like. So now I'm going to pull back on the control yoke here. I'm going to get there's the 60 degrees right there. Really hard done. Okay, so that's a 60. That's a little bit more than a 60 degree, but it gives you an idea of how it works there. So let me get to the back later. Okay, so this is a 60-degree bank right here, and we've got. You can see the difference. Well, this is just slightly over a 60-degree. 60-degree bank right there. It's maybe like, it's maybe 65, 70 degrees, which is what we classify as anything over 45 degrees we consider a steep bank. And now you can see that most of the force of the plane, that angle of attack, is actually going in that direction, right? It's pointing in that direction. It's not pointing up like it was before. So we really have to pull back on the control yoke because we need to counteract the loss of lift from the wings now. So we've got to increase our angle of attack. We want to pull the aircraft and turn in that direction. So what's happening here is we've got the control gear, the elevators pulled back. We've got a high angle of attack now, or higher angle of attack, to maintain that turn. And again, this is where we're actually feeling about 2 G's of force. So if you weigh 100 pounds, you're going to feel like you weigh 200 pounds at this point in this turn right here, if you actually maintain that turn there. So those are some of the different forces that are at work. The plane still weighs, 1,000 pounds, but because we've got that G force on it, now the aircraft essentially feels it's got a 2,000 pound load that it has to maintain. So these wings here have to be able to withstand 2,000 pounds of weight at this turn. Anything less than that, and they'll break off. So that's why we have like load limit factors on aircraft. They have various limitations that you're going to see with general aviation aircraft. Typically, it's if a plane weighs 1,000 pounds, the max G forces it typically can take would be like 3.8, which would be 3,800 pounds. Essentially, that thing has to be able to support 3,800 pounds. So, right. So again, in flight, if we want to turn, what causes the plane to turn? Okay. Say it again. Pitch it back. Yep. Yep. So you're going to bank into the turn and you're going to pitch into the turn. It's that the elevator is actually what's causing is pushing the plane into the turn. So if we want to do a level turn, okay. So if we just want to do a descending turn, we can probably just bank it, and then just maybe pull back in the elevator very slightly. But if you want to maintain your altitude and go into a turn, you're going to bank into it, pull back in the elevator, and it's going to push the plane into the turn. The elevator is going to cause it to pitch into that turn. Okay. And the more bank we have, if we stay at, and this is assuming we stay at a constant altitude here, the more bank we have, the more elevator we're going to have to push into that turn, because we're losing. You can see here when I bank this, if you look at right now, the Earth sees this whole wing right here. That whole wing now is producing enough lift in the plane itself to keep it up in the air. So if this weighs 1,000 pounds, we're producing 1,000 pounds going up in this direction. But when I go like this, now the plane is no longer producing lift in that direction. Could you try? It's no longer producing lift in this direction. Well, it's producing lift in this direction, or I should say lift straight up like this, but it's not as much as it would be if it was like this. Here's less lift. Now it's producing lift in that direction. So what we need to do is increase our angle of attack, which increases the lift of the plane, and it causes it to go into that direction. Don't worry about it if you don't understand this completely. Not everybody does. But like I said, if you have questions on it, definitely talk to me about it, because we try to get it to so that you guys can describe it at least to an examiner. You'll need to know this obviously for the test, the exam. They'll talk about the horizontal component of lift. So if I were to vertical component of lift, they talk about those things. So vertical component of lift is always literally vertical. It's what's up in there. So even though the plane is banked like this, there's still a vertical component of lift. In a turn, there's also a horizontal component of lift. So there's this lift right here. That's what the horizontal component of lift is, what causes the plane to turn. And that's because we're pulling back from the elevator. Pulling back, it's creating horizontal lift in that direction. And same over here. We still have a vertical component of lift. It may be less, but it's still, if we have a horizontal component of lift, now we're pulling the plane or pushing the plane in that direction. That's called the pressure we feel in the seat of our pants is called centrifugal force. So the plane, and that's just like if you were to take a ball, tie it to a string, and swing it around, you'd feel there's centrifugal force on the ball. You kind of feel it as you're swinging it around there. Let's see. Yeah, so the one thing that it's always a gotcha, sometimes people get load and weight confused. And I'll just bring this up just in case there's any confusion on it. The weight of the aircraft never changes. If it's 1,000 pounds when you take off, it's going to be 1,000 pounds in the air. There's no difference, unless obviously you're burning off fuel and things like that, or throw something out of the plane. But generally speaking, the weight is not going to change in the aircraft. What does change is the load factor. So this is one thing that we'll talk about later on too, when we get into stalls later on here. If you go into a steep turn and you pull back real aggressively, there's a possibility you could do what's called an accelerated stall. And that's because the aircraft feels like it is, like if you roll into, like, let's say a 60-degree bank, okay, so now we're pulling 2 G's, which is twice the weight of the aircraft. So the aircraft weighs 1,000 pounds right here, we go into a 60-degree bank, it's now weighing twice that. So it now weighs 2,000 pounds. So the wings at some point can't, keep that maintain that amount of lift for that plane. So it's eventually going to do what we call an accelerated maneuver stall, and the wings stop producing sufficient lift to keep it up in the air, and it just falls out of the turn. It's what happens is essentially if you're doing a coordinated turn, it just kind of falls out like that. It's nothing really, doesn't do anything crazy or anything like that, unless you're not coordinated right with your rudder pedals. So I'll get into that later on too. So, all right, so. Forces in climbs. All right, so this is another one that there seems to be a bit of confusion, even amongst pilots, believe it or not. So, when we want to climb, normally what we're going to do is we're going to fly. That was the first thing we do when we want to climb. Pull the pitch back, yeah. But we know when we pull the pitch back, what's going to happen to the plane if it's a positively static, stable aircraft. So if it's going to go back. Yeah, it's going to go right back down to where we left it at. So that means we have to hold back on the control yoke to get it to stay in that climb. Can you guess what's going to happen to the airspeed if I pull back on the control yoke? It's going to decrease. Yeah, it's going to slow down because you pitch up like this, you're developing more lift, yes, but you're also creating more drag in the aircraft itself. It's actually generating, more drag. So to counteract that, we're going to do a couple things. Number one, we're probably going to add power to get it to go up. So what happens when we pitch up we're actually changing our angle of attack slightly for a second, and that just changes the direction the plane is flying in. The angle of attack does not stay like this. Right, so this is the misconception that a lot of people have. Let me just show this here. So we're flying along. This pencil represents our flight path and angle of attack right there. So we're flying like this. There's our angle of attack, okay? We want to climb. So we have to pitch the nose up like that. The plane then starts its climb. We give it more power, we trim it up. But the angle of attack starts going down. But I'm sorry, you guys can't see this here. But when you first go into a climb, we increase the angle of attack like this, and then the plane starts climbing. But that angle of attack goes right back to where it was in steady flight. Okay, that's an important point to remember. Because a lot of times what people think is when you pitch up the aircraft, it is the angle of attack is going to stay at that high angle of attack. That's not the case, because again, we know from what we've talked about before that the chord line of the wing itself is and the flight path dictate what the angle of attack is. And if we're climbing, that means our flight path is like this. Our angle of attack now is going to be roughly where it was when we were at, flying straight and level. And that's if we have enough power. At some point, the engine's not going to produce enough power to keep climbing. You get up to around, in some aircraft, maybe 10, 12,000 feet, and there's just not enough air for the engine to breathe. And so it's just kind of peters out and just stays at that altitude. It won't go any higher than that. To get the aircraft to go into a climb, we pitch up, and then we trim up and add power to it. And then the plane will continue on in that. Again, basically same angle of attack that we had when we were flying straight and level. And that is if you were flying at the same airspeed. So let's say we were flying at 100 knots. Here, we want to climb at 100 knots. We give it more power, pitch up a little bit. The plane starts to climb at 100 knots. That angle of attack is going to be the same as if it were at the when it was flying straight and level. Okay. To descend, again, in the cockpit, all we have to do to get it to descend is push the nose down, right? But what's going to happen if we do that? We push the yoke in, the nose goes down, we don't do anything else, what's going to happen in the plane? Speed up. It's going to speed up, and it's going to produce what? More lift, and it's going to cause the plane to climb. It's going to go back up like this. It's going to pitch up back. It's going to try to get back to that equilibrium. So that means if we want to descend, what can we do? We can hold the control yoke forward and force it down. What's going to happen to our airspeed if we do that? It's going to increase, yeah. So when we descend, we relax or pull back on or actually push down the control yoke and pull back on the power typically, unless you want to climb it or descend at a faster speed. If you're but if you want to descend at the same speed that you're cruising at, let's say 100 knots, I want to descend at 100 knots. Well, really all I have to do is bring the power back, and that plane is going to find that new equilibrium. It's going to try to, the nose is just naturally going to pitch down. Let's actually demonstrate it on here. You'll actually see it a little better here in the sim. So here, all right. So what I'm going to do here is I'm just going to chop the throttle. Watch what happens. Watch the airspeed in particular. Our airspeed's going down just a little bit. We're still a bit of a climb. So we're at about 120 knots. I'm just going to bring the power back here. So our airspeed is pretty much staying right in that area. It's going to drop down. If I just let it stay like this, what's going to happen over time is now it's building. The airplane's building up airspeed. Watch what happens next here. And then takes a second. Planes, there's always a delay there. And now we can start seeing the airspeed is starting to go down. And if you look really carefully at the plane, it is very slowly starting to pitch up. And it's supposed to anyway. It's not doing that. So it was a good demonstration of it. It's oh, I know what's going on there. So let's get back up to altitude here. So this is adding power here. Let's get our wings level. So right now we're in a climb. You can see our airspeed is dropping a little bit here. I'm not touching the controls here. See how the nose is kind of falling back down? That's that oscillation there. The same thing would happen if I were to reduce power. Let's see if we can get it stable here. The problem with these things is it's not always perfectly stable. It's very easy to demonstrate this in a real aircraft. You can actually feel it. You do that. So, and notice this. So there's the attitude of the aircraft, but also notice our airspeed indicator. So right now it's at 90, and as it increases, the pitch is dropping a little bit. So that's kind of an oscillation there. So what's going to happen here? I'm going to go ahead and bring back our power, and we'll just see what happens here. So I'm reducing power, and now we can see the plane. I'm just going to straighten the wings out a little bit here. So reduce power, and see now the nose is starting to drop down. Okay, and we're building up airspeed now. That's because when in most aircraft, when you pull back the power, it doesn't necessarily immediately change the pitch of the aircraft. It does take some time. We're actually seeing effects of static and dynamic stability here in the aircraft here. So, all right. So I guess all that to say is that when you pull back power, the nose is going to just drop a little bit, and it's going to descend. But because it's descending, you're not touching the controls. It's going to build up more airspeed. More airspeed produces more lift. More lift produces, once it gets it's going to get the plane to actually go into a bit of a climb, and you get those oscillations. So that's essentially what happens in a descent. So again, to start a descent, we typically the first thing we're going to do in the plane is usually bring back the power, and then push the nose down. We would trim the aircraft for a descent. If we're at 6,000 feet, we want to get down to 2,000 feet. First thing we're going to do is pull power back, and then we'll Oftentimes what I do is I just pull the power back and let the plane start its own descent. And it's most of the planes you fly, it's very stable. It's just going to start doing a descent and maintain that for a long period of time here. So I'm doing good time here. Why don't we take a quick break here, guys? And then I'll let you guys take a breather, and then we'll jump back into this and we'll dive into stalls. Any questions up to this point, though?
There it is.
Oh, air coupe. Yeah.
It's in
This one?
Yes.
Yeah, is that Tom's? Or is it?
It's scratched up. I don't know.
I think I just saw him when he was over at Bear. He's rebuilding the engine in it. If that's Tom Parker's.
I don't think you've gotten my picture yet.
Let's do that right now. Do you have a second?
It looks a little beat up. It's been running for about 50 years. 1946 air coupe. Faster than you know. Gotta be honest. You know this picture.
Gosh, I don't know. I don't think so. He's the owner.
Apparently, yeah.
Or
it's just like a quiet.
You could check. I don't know if Tom is here today. He's usually off on. He's the airport manager here. Tom is.
Well, obviously, I'm not rich enough to buy that. So.
Actually, those are very reasonably priced aircraft. Not that it's like anybody's. It definitely would be less than most. Nice. Oh yeah, definitely. What's that? Oh, perfect. Okay.
I just remembered a story. So, my grandpa down in Kansas,
Uh-huh.
I remember he met a guy who was like the first person to put like a ginormous engine on like a smaller plane or something.
Mm-hmm.
And I remember he apparently was flying in that to like repossess a pickup or something. And he was having the guy fly him down there.
Uh-huh.
And when he said that it felt like the plane was going to fall apart, he was shaking so much.
Oh yeah. Some of those older planes do. It's like
Apparently, like he was in some Paris or something race, but then something was wrong with his head. It was just too big.
Uh-huh.
He ended up flying under the Eiffel Tower.
Really? Wow, that's
I don't know.
crazy.
It just like my mom was just looking through a autobiography and just saw it, and it was like, I think my dad is that. Yeah,
Fascinating. That's fascinating. Yeah, if it's do you know, was it a radial engine or
maybe it was like a Oh, no, I'd have to look into
It's like,
it. Yeah, it's interesting.
Yes, some
Down in
engines,
Kansas.
the general rule of thumb is the more cylinders a engine has, the usually the smoother it runs. You know, if you have a 4-cylinder engine, like a 2-cylinder is going to vibrate. Well, like the Harleys, you know, everybody loves Harleys, you know, but they make so much noise. But if you look at the engines, that's because of the way they're designed. They've got really good isolation mounts. The engines that keep it, you know, shaking tighter. It's easy. But like 4-cylinder engines are going to use a little bit of initial vibration. 6-cylinder engine. So the smoothest aircraft I've flown is 6-cylinder. And the radial engine. So
Joe, what is dual received in like pilots? Or do you have to put anything else?
yeah, dual is when you are flying with a flight instructor.
Yeah.
Yeah, so they're gonna put that time in.
Oh,
That is dual the instruction time essentially. And then PIC time is when you do your first solo. You're going to be pilot in command, so you're going to be able to log that as PIC, as you will be, you know, pilot in command in that. So
Because I'm going with Wanda and
Excellent.
person tomorrow.
excellent.
So,
Uh-huh.
fly out of like, so,
Where are you guys going?
I don't know,
Just
wherever.
someplace.
Yeah.
Yeah, that's a great. I mean, this is I'm glad you brought this up, Cadence. But if you guys, you know, if you hang around the airports, there's a lot of pilots that are typically flying someplace, and they'll just bring you along if you want to go for a flight. You know,
Honda's pretty awesome.
yes, Bond is excellent. She'll if I know if she's going someplace, she hates having empty seats. I'm the same way too. If I fly to a client or something like that, I hate having an empty seat. But the problem is, it's business days. Yeah, it's like usually it's short notice for me, and I can't always have somebody. I'll post it if you guys ever want to fly with me to some clients. Yeah.
Yeah, speaking of that, I remember, well, it was the Young Eagles program, but we were down in Oshkosh at the EAA museum, and they have a big area, and then they have all those kind of smaller hangars that are near the that grass or dirt runway. Where there's a building in there, and you can go there and you can talk to them about it. And if you're like, I think if you're under 16, then yeah, that's still.
They just did it.
And I just did it. Me and my little brother did it.
That's awesome. Yeah,
It was
take
just
advantage of that.
First time, and I was just like, that was fun. And I did it for like 5-30 seconds.
Excellent. Yeah, that's awesome. That's awesome. Like I said, you guys, if you do get to airports, again, we've got Baraboo, Reedsburg, Portage, Sauk. If you know of a pilot, maybe just talk to them. I can get you in touch with other pilots. There's a lot of corporate planes that fly out there. They have some limitations, the liability issues there, so you may not be able to fly on those, but maybe we could work something out and get you guys on board with these planes here. And like I said, every time I fly, I hate having empty seats. Go sit there. So let's talk really quick about stalls, and then we're gonna turn it over to Lieutenant Colonel Dan Barr, who's here. A stall. So what is a stall? Can you guys anybody tell me what a stall is? Kids, yeah.
When the airplane doesn't have sufficient.
Yes, it stops producing sufficient lift to keep it at the altitude that it's at. So okay, so there's angle of attack. We know what angle of attack is, right? So our flight path is in this direction. What is the angle of attack definition? Let me remember what the terms are.
The chord of a.
What's the chord line?
Chord line.
The leading edge to the trailing edge. Okay, so you've got. So this right here is our flight path. Right there, it's like this. Right there, right. Our chord line is from the trailing edge to the leading edge. In this case, it's like this. So you can kind of see. There's our angle of attack right there. So the plane in this case is flying in this direction right here. There's our angle of attack right there. Again, the pencil is the chord line. This pen down here is the flight path. So we need that. So there's this thing called, what happens when we get to the maximum angle of attack? What is that? What's the term used? Critical angle of attack. What happens at the critical angle of attack? Yeah, the plane just cannot produce enough, lift. What happens is, technically what's happening is as the air is flying, so we get to our critical angle of attack, right, like this, right? What's happening is the air hits the front of the wing, and instead of flowing over it like in a nice laminar flow like this, it starts separating from it, and you get these burbles. And again, I've mentioned, I think there's a couple of videos on the SIA website that you can look up in the lessons there that actually show what they did was they taped yarn onto the tops of the wings. And you can see, first off, when it's flying straight level like this, the yarn is just pointing straight back. It's just fluttering around like this. And it's literally taped onto the tops of the wings there. But then when it gets close to stall, you can actually see how it increases the yarn starts fluttering around on the base of the wing there. On this half of the wing, it just starts fanning out like in this direction like that. That's what it looks like on there. You actually see it. So critical angle of attack is again that point where the wing is not producing sufficient lift and the plane stalls. That's all you have to know. Let me just see how well you understand this. Does a plane always stall at a specific speed?
No.
Great. Okay. See, you guys you actually are so far ahead of so many students. So perfect. It can install in any condition, any attitude at all. That's something we all need to understand, including all the pilots that fly planes. The reason for that is, again, you could be at any angle of attack anywhere. If my flight path is, just by looking at the plane, I don't know what the flight path is. If I just hold it here, we don't know if the plane's going this way, if it's going this way or whatever, or if it's going like this. So by having those by knowing the path of the aircraft, we now know what could happen to the angle of attack, or what is happening to the angle of attack there on it. So that's all I really had. You guys, we already covered a lot of the stalls before, so I'm not going to get a whole lot into that. We'll pick up next week, and then we're going to dive right into instruments next week. So there's a couple other things we're going to talk about. I was hoping that Jason talk about the 4 turning forces this week, but we're not going to get to it. I want to get Colonel Bar in here and get him started. So any questions on stalls? You guys, everybody understand? Okay, perfect. We get this cleaned up and we get let's see here.
Yeah, that was 2 years ago. Bring shots at it. One of the best in the state. So we can sell things. Most people need so needs a new battery. We do MIG, we do TIG, stick, and obviously a settle. Yeah, but everyone's really fun.
Lieutenant Colonel Dan Bar.
Good morning, everybody.
Watch that. Get this all cleared up.
Are you all like studying at the same pace of material? Like, was there a topic for today, or
Yeah.
what was today's topic?
It's kind of a mix aerodynamics primarily. Yeah.
Aerodynamics, shapes of wings. And then also a lot of stuff.
Like,
Static. Static.
All right, and you have a computer. Oh, you want me to get that hooked up for you? Perfect. Okay.
It's going about 600.
Okay, so this is
20.
oh god. Yep.
They're pretty
And
good.
then we've
Well,
got a
still.
camera right there. I'll try to. You can. Actually, if you stand up, I think you should be able to. Chris is taller than I am.
Sit down too.
I can. It's up to you. If you want to sit down, I can sit here. If you want to talk,
Me and my buddy Johnny were going for speed. Just having people have dialed in so that we could get more comfortable with different speeds and stuff.
So usually a lot of them just watch later on. Show. I'm making this cool.
They actually go online and watch it.
And as a class, do you like to go by Mr. Joe, or
Just Joe was fine with me. Yep.
so you guys had a commercial pilot come last week, I think. Cool. I have some slides, and that's just to make sure that I cover everything. But who's heard of the Air Force Academy before? And then just to give you a good sense, raise your hand. 9th grade. Hands from 10th grade. 11th. Okay, and then seniors. So again, my name is Lieutenant Colonel Dan Barr. Right now, I'm actually serving with the Wisconsin Air National Guard, but I'm a 2009 U.S. Air Force Academy graduate, and it's out in Colorado Springs. And I really just wanted to come in, make sure that you all are aware of the Air Force Academy. I'm the admissions liaison officer for the state of Wisconsin, and I'm here to help answer any questions that you have, whether you're interested in serving and pursuing being a pilot or serving in different ways. But the Air Force Academy, unless we have an okay social media presence out there, but it tends to be, it's like a word of mouth deal. So I just want to make sure that you guys are tracking things. But we are a 4-year institution out in Colorado Springs. It is a government military school, right? So when you think about like the standard, you wake up every day, you're wearing a uniform, you're going to class, sometimes you're marching to and from different places. This is that school. And it also provides an avenue towards going to the U.S. Space Force. But we're not as old as Annapolis or West Point. We're only about, I think we're coming up on 70 years old, right? It was kind of a post-World War II thing. And it is an amazing place. So who's ever been out to Colorado? Very cool. You get to wake up every day, see the Rocky Mountains, breathe that thin air, and then you can see the academy itself, the beautiful campus. Unlike other colleges where you're sort of like sprawled out, what's really cool about the academy is this area, this box, represents like 90% of your daily life, because on these 2 areas you have 2 gigantic dorms. Like one of them is a quarter-mile long, and the other one's about like an 1/8 of a mile long. And then you have your location where you eat, where you study, and then just on the other side of it, places to go work out, do sports and things like that. It's a really special place. It's not a very big academy. It's about 4,000 people. So if you compare that to a big school like Madison or Ohio State, it seems small, but it's mid-size. What we do at the Air Force Academy is when you're going through the 4-year program, you are set up to look like a Air Force wing. So you have all these different cadet squadrons that you live together, you study together, you train together. It's a really special place. And it's for me, it's where I've met some of like most impactful people and friends that I've ever had. So I like to joke, because depending if you're a Harry Potter fan or not, I also like to pitch this place. It's like the closest thing to Hogwarts in the real world. And I see that, like, I know it's a very serious school. You're going to train to do some very serious stuff out in the world, but it does, in my mind, have like the close feel to that, where you're very bonded, you're very tight together, and you get to do some really cool stuff. Raise your hand if you guys have any questions along the way. But here's our mission. It's not just to go to the Air Force Academy to be at the Air Force Academy. It's a 4-year program. There's really not like a 5th-year option or 6-year option there. It's all for your undergraduate and commissioning. But the ultimate goal is to create officers of character. Right? The Air Force Academy is probably the best military location to become a pilot, if that's your ultimate goal. But we also offer a lot of different other career paths if you're interested. But that's the bottom line at the end of the day, is things that you can do there, like traveling around the world. I've got to go to Africa and Europe on language immersions, or jumping out of airplanes, or flying the good ones. The whole goal is for that, for people that want to become an Air Force officer and lead. This is like the greatest place to do that. Yeah, we believe in developing the whole person. It's a 4-year school. It is a military school, but you have a very rigorous course load of military training. You know, right at the beginning, we do have a basic training where you will be marched around. You'll be eating at attention, and it's a very tough environment. but we also have like a really rigorous academic program there. Whether you want to be an English major or aeronautical engineer, every one that graduates from the Air Force Academy, it's with Bachelor of Science. So we have a lot of high expectations for folks that go there to make sure that they're comfortable with doing things like advanced math, physics, chemistry. And then we have a lot of programs there that can help develop you, but it is a very tough academic school. Average semester, if this number makes sense to you, is probably going to be about 18 credit hours per semester. And that can be like for the whole way through. And if you're really ambitious and you want to double major, things like that, the bar is set really high to accomplish those things. And athletics, this is a place where you have to take fitness tests twice a year. You have to take a fitness test for entrance. And again, that we're just trying to develop the whole person. Hopefully you're someone that wants to go there and enjoys being physically fit and helping other people get fit. Yeah.
Did you play any sports or were you like because I know you have
Yep.
to be in like fitness club, right?
Yeah. Yeah. Sports are mandatory. And in fact, even we have to take PE classes there. Now, they're really fun PE classes, like boxing, unarmed combat, scuba diving. And then I had to take tennis. I was really bad at tennis. In fact, I think that was my worst PE class I took there. I was able to hold my own in the boxing ring, but then I just got destroyed on the tennis court. So yeah, we have mandatory PE courses. You have to train for what's called the physical fitness test every year, which involves push-ups, pull-ups, sit-ups, standing long jump, 600-meter dash, which most people puke at the end of it because you want to push yourself really hard. And then on a separate day, a timed mile-and-a-half run. So anyone with those cross-country vibes in here, it kind of had that feel. And then, yeah, we have mandatory things. If you're not a NCAA Division I athlete doing one of those things, you have to do intramural sports or specialized club sports where people will do things like train for an Ironman triathlon or a marathon, rock climbing, all sorts of cool stuff. But yeah, fitness, big part of our culture there. And then I always like to harp on this because after you've been through a special place like the Air Force Academy, we have a very strict honor code. A lot of schools, even your high schools, probably have academic honor codes, right? We live and breathe the honor code where, I mean, if someone asked you, did you brush your teeth this morning? And you said no, and it was a lie, culturally, we have a significant problem with that. Now, I would think for you all in aviation, where what you're training to do, what you're learning to do is very serious. You want to make sure that you're living and working around people that embody that, where someone's going to say that your plane is ready to fly. You don't even have to question, right? You shouldn't have to because you can trust them. And so that's what we're trying to do at the Air Force Academy is develop a culture of trust. If you decide to go there, you get to go through a lot of unique experiences. I'm not trying to downplay other universities and the unique things that they have, but you get to start your college experience going through basic cadet training, which is really cool. It's everything you thought basic training would be in terms of obstacle courses, dragging around the ground with a rifle, learning how to march, working as a team, very strict. I mean, it's really neat where you're only allowed to like talk in a certain language, vernaculars, like basic statements you can use. And it's 6 weeks. Oh, yeah. Finish. And it's a 6-week experience. And then your congratulations, you got done basic training. Now you get to start academics right away. And then you go into your course load and your opportunity to do other really neat things.
Is there an academic requirement from high school that you to get into this?
Yeah, there sure is. And I'll cover those near the end as far as like what we talk about, like the numbers, the goals you should be striving towards. Very good question. And yeah, along the way, 4 years, hard academics, lots of programs, but we also make sure that we're starting to develop you as a grown-up, as an officer. So you mature very quickly at the academy. There's really not a lot of room to sort of like get lazy. There is no like, hey, can I take a break this week? Like classes are mandatory. You have to keep going and going. And it's a wonderful challenge. Anyone interested in any of these degrees? because not to brag too much, but you can see the numbers here. I mean, thousands of universities, and here's our rankings. So extremely high on aerospace, aeronautical engineering. Incredibly demanding program. I didn't do the aero or astro approach, but my friends did, and they paid a huge price to even just complete that program. But they learned a ton, and they really grew as a person. So extremely good STEM programs. If you decide to go to the Air Force Academy, again, more bragging. It feels nice to be up here talking about this. Our professors, it's a mix of military officers and permanent civilian professors. But what's really cool about this place, no one, as far as professors go, are there to work on their PhD to publish their paper. Their sole purpose is to be there for you and make sure that you are learning, that you're developing. So it's a special place where you can go to a professor's office and say, hey, I need some extra help. And they are 100% there for you. They're not going to say like, I'm busy or I've got to publish this paper, otherwise I'm going to lose my job. So in terms of academic support, it's world class. And yeah, we do get special visitors there once in a while. Have you guys seen him with that jacket on? No, Elon Musk? Okay. Yeah. Wide range of majors. You don't have to study aeronautical or astronautical engineering there. And in fact, for me, I ended up studying political science, and I minored in French. So I enjoy foreign languages. I like studying political science. I still had to take things like computer science, electrical engineering. It's just like the core class load, but it was absolutely worth it because then my professional life, knowing that I've taken those technical courses, paid off.
What is space warfighting?
Space warfighting, yeah. So the Air Force Academy is unofficially now also the Air and Space Force Academy. So what we offer that a lot of other universities don't would be classes that involve studying military strategy, right? That is the entire design of the course. So for a space warfighting minor, it just means that you've taken a select list of classes that focus on military strategy in space. It's pretty cool stuff, yeah. Any other questions about our programs, academics?
Minors need to take.
I think there's a limit until your brain explodes. So most people usually choose like one minor.
Interesting.
Right, so there's a whole world of how do you actually move stuff around the planet. And it's not as easy just like getting it on a plane. So it's actually a really cool program where you can study like, here's how civilian people move equipment and people around the world. Here's how the military does it. So you have an interest in logistics.
What is a nuclear weapons strategy all about?
What do you think it's about?
Learning about the economic bomb, or?
Yeah, it's an entirely different level of studying warfare when you start talking like nuclear strategy. But what's awesome is this is the place where you can actually slow down, work with world-class professors, and study these type of things before you went off and commission as an officer. Pretty cool, huh? Athletics, we are a D1 institution, and with only 4,000 people, you end up with a pretty good chunk of the population also being D1 athletes. But you don't have to be a football player or wrestler or elite cross country runner to attend, but it's a huge part of our culture. So we support the football games, and we have excellent club sports. We have like our own, where they're not, D1 sports, but we have things like a triathlon team, our own CrossFit competitors, and people that go to things like even competitive rock climbing. Being in Colorado, it's like a giant playground. If you're an outdoorsy person in Wisconsin, you can relate to being an outdoorsy person in Colorado, but you get exposure to a lot of different things. And yeah, we take squadron pride pretty well, and we enjoy competing with each other a lot. So we'll do things like dodgeball, cross country, ultimate frisbee. Sports are a big thing, and our fitness tests. We have tons of clubs. If you have an interest, odds are the Academy has something for you in terms of an extra club where you can bond with people, where it can be additional sports. if you're interested in flying, we have not just like formal flying programs that actually count as like an academic college course, but we also have flying clubs where people, can rent planes, fly together, and do a lot of different things. My big sport was, or my big club was the marathon club. So we would get together on the weekends, do long runs, train for things like the Boston Marathon, and push each other really hard. But if you look at this list, you should be seeing something that could pique your interest. It's like cross country skiing. Yeah.
What's the difference between that skiing and freestyle skiing?
Freestyle up in the mountains. So, where's the nearest ski place here? Yeah. So with Cascade, imagine a mountain area, but it's like 10 times as tall, and it could take like 15 to 20 minutes to actually get all the way down. So that'd be more like freestyle skiing.
Do you have to apply for a club and like be like do like a get in through like tests and stuff?
Most of them are open clubs. There are things like up here, like the flying team, where you do actually have to interview and apply. We also have a jump program. So the Air Force Academy has a program for skydiving, basically. It's the only place in the world where your first jump while skydiving is solo, and it's free fall. So it's a ground school like what you're experiencing here, except for jumping out of an airplane, and it's all on you. If you enjoy that, then you can continue on what's called the Wings of Green and the Wings of Blue program, where by the time you graduate, you could be close to like 700 jumps out of an airplane skydiving. The best part is it's free. The Air Force Academy is paying for a club like that. That'd be an example of like more like a closed club where you have to actually apply and compete for. Most are open.
So is there like a limit of how many clubs you can take, or
time management is one of those things that you learn really, really well. So you can do a lot of different clubs, but based on just the academic course load, the military requirements, fitness requirements, like you will max out in terms of free time. If you're a person that thrives in that environment where you know that you actually have more to do than time available in a day, and you have to start making decisions as to what you're going to do with your time, this is the place for that. But you can dabble if you want over the 4 years.
Have you ever seen the Falconry Club doing that thing? Or?
Yeah, the Falconry, they get invited to so Falconry, if everyone knows, it's actually like training and working with a falcon where it can go out, it can grab things from the air, it can do like its own little aerial demonstration. But yeah, they're often at football games or other events.
And follow up. Does everyone have like their own falcon? Or?
I actually don't know. I don't know if it's 1-to-1, but there is a special building down by the athletic grounds where they keep all the falcons and get them outside of training. Yeah, that's another special building.
how do you get accepted?
Great question. I've got slides for that. Because applying to the academy again is not going to be like applying to UW or any other local school. Yeah, while you're there, you can do things like travel. You can even spend a semester at a different military academy. So like my roommate went to West Point out in New York. So that's the U.S. Military Academy for the Army. And you can get a broad experience out there. You can do things like cultural or language immersion. So for me, I grew up in Cleveland, Ohio, and then I got to travel to Western Africa and Saharan Africa, so Morocco and Senegal, and do a language immersion for a few weeks. Again, this is a very unique program because you're there. It's again zero cost. So this isn't like applying and getting into student debt to go do these cool things. This is just part of what they want to do for you. And you can do research. You can do Ops Air Force programs where your summer break at the Air Force Academy is not months long; it's weeks long. So because I think we have like one of the longest academic calendars in the year. Your summer break is really 9 weeks, and it's broken into 3-week chunks. 2 of those 3-week chunks is probably going to be a military training program, and then going to an Air Force base for 3 weeks, and then you get a 3-week summer break. So that's all you get. But I always enjoyed that because my summer breaks were not about working at Chipotle or shucking pizzas around town. It was going out into the world and getting to do these things. So I always felt very, very lucky to be doing this instead of some other summer jobs. No dig to the summer jobs. We have our own survival and evasion program where we send you up into the woods and you actually learn how to survive on your own. Our basic training is also unique because it's, you guys ever see like those like brown smoky top hats, right, in Hollywood movies? There will be a couple of those, but what's really cool about our basic training is it's cadets that will teach the other cadets. So it's a very closed leadership system where you try to quickly figure out if you're this person, how do you lead and train and develop others? And then you can also do things like take summer academics if you're kind of triple major or do some crazy things. More towards airmanship, we have, like I mentioned, Wings of Blue, which is a dedicated skydiving program, and they get invited all around the world for skydiving competitions or doing like demonstrations at football games. Pretty cool stuff. And then our powered flight program. So this maybe resonates a little bit closer with what you guys are doing here. It's an academic program that will take you through things like what you're doing now for basic ground school and eventually soloing with our airplanes. And if you enjoy the power flight program, you can do things like an aero club and continue your flying. But yeah, the Air Force Academy is each year gets more pilot slots after graduation than most ROTC programs, and same thing with the other branches. It is the place to become a pilot. We also have a world-class soaring program. So if you feel like you're not quite ready yet for something with powered flight, we have gliders that will get towed up several thousand feet, detached from an airplane, and then you can actually practice airmanship just without a motor. It's a pretty cool program. If you're into computers and other types of technology, which is what I do now, we also have things like a pretend city that these guys are learning how to hack. So it's set up and you can really practice a lot of neat parts of warfare, but the Air Force Academy is starting to expand beyond just the idea of pilots. And like I mentioned, space, satellites. My wife is also a Air Force Academy graduate, and while she was there, she got to, as they say, fly a satellite up in space, but cadets actually designed and engineered a satellite, and they had the U.S. Air Force launch it into space, and then using antennas at the Air Force Academy, they were actually able to talk to that satellite and do experiments. So, a lot of cool opportunities. And then our jump program, and then graduation. Yeah, we've had a lot of different distinguished graduates. Sully Sullenberger, have you guys studied that on the Potomac? So Air Force Academy graduate, he came back and spoke to us. Pretty amazing what Air Force Academy graduates go out and do in the world. And then, yeah, this is like the place if you want to go and become a pilot, whether you want to do manned or unmanned stuff. But we also do a lot of other. There are also a lot of other jobs in the Air Force where maybe if you're like me and you just really like being around the flying world, but you're not a pilot, we have tons of jobs and opportunities for that. It's super cool. Yeah. This is like just a sample of all the different jobs that you can do in the Air Force. So when you go to the Air Force Academy, you'll find out what job you're going to get in your junior year, and then you can go carry on to that. And then your senior year, you'll find out where you go and get your first assignment to after you graduate. But yeah, what's really amazing about this place is not only is it free, but you actually get paid to go there. So everything's covered: room, board, food. You don't have to worry about where you're going to get your meal. We have a dining hall, and everything's provided for you at no cost. You even get things like free healthcare, which is probably like a boring topic to you all, but your parents would probably even appreciate hearing like, "Oh wow, you're going to go there and get free healthcare for 4 years?" Like, yes, go. But it's a special place, and we even do some financial incentives like your junior year. You can get a super low interest rate loan, so you can start saving up for your retirement way, way down the line. But there's a lot of things the Air Force Academy does to take care of you because you are committing yourself to serving.
How good is the food?
I liked it, and then especially I still think about it because there were no dishes. Like I love that part. But I thought it was really good. We always had like it was like lasagna, or we did have a Taco Tuesday. But yeah, 3 hot meals a day, and then if you didn't want that, you can do things like cereal and snacks. But it was supreme. We had this special dessert called like Mitch's Mountain, which was just this giant pile of ice cream that a whole table split. You can eat on your own, but it's also very communal, right? You never have to feel like you have to like go eat alone at a booth by yourself. It's always like community sitting and eating together. Another question.
I heard that pretty much every other part of the military do food is crap except for the Air Force, pretty much.
Yeah, I don't know what it is. I've never really had to eat at other dining locations except for Air Force ones, but I've always been. So. All right. Oh yeah.
Oh, I was just gonna, are you gonna talk about schools?
Sure am. Yeah.
Oh, okay, I'll let you go.
Right. So, what makes applying to the Air Force Academy different than other places is how big the application is and how long it can be. And in fact, not speaking for myself, and not just for the Air Force Academy, I like that it's long and hard because we're going to find out really quick. Are you just curious about the Air Force Academy and serving in the Air Force, or are you actually like determined to get to this place? Because it could take a lot. We take a look, obviously, at your academic, prowess, your ability, what you think you can handle. But we also do things like a fitness test as part of your college entrance, where you have to get together with a person like me or your PE coach and run through a fitness test and then submit that. When I first applied to the Air Force Academy, there was one component that I did not hit the minimum on, and I submitted my scores. I was 1 inch shy on standing long jump, and they came back and said, "You're not coming unless you get that score up." So I had to retrain, take the test again, and then finally got it. But there's no messing around with standards if you're going to the Air Force Academy. And then also going through a medically qualifying board. So we have a Department of Defense Medical Evaluation Review Board, which you just have to like go to a local doctor and get a physical checkup. But it's good if you're interested in a place like that, being wide open in terms of if you have like medical conditions, don't self-eliminate yourself by not applying. Go through the application process, and then you can find out, one, if you're just medically good to go, or maybe you have some condition that just might require a waiver. But a lot of folks, when they see like, oh, I have to go to like get a doctor's appointment to apply this place, I'm not applying. Good, because then you probably might not have a great chance of surviving rigorous 4 years if one doctor's appointment is going to stand in your way. And then character and leadership, we take a look at what are you doing. You don't have to be the NHS president, student council president, name your other club president, and then on your application, I see how are you president of 5 different organizations and actually provide quality leadership to other people. You're probably doing that just to pad your resume. So we're looking for people that are joining clubs, helping others, leading others, but are actually doing a really good job at it and not just showing up to the meeting, right? Signing in and be like, yep, I was here, just so you can put it on your college resume. We want leaders. And then another tough part is you have to get the Air Force Academy to say, yep, you meet our standards. We'd love to have you. We also need a nomination from either the president, the vice president, or your Senate, or your House of Representative congressperson. Can everyone name the local House representative? Depends on your district. Yeah, everyone is. So that's the other hard part is you will have to go through another round of applications and interviews with your representative. What's really cool about the Air Force Academy is that there are X number of slots and it's given down to congressional leaders to provide nominations for people. So yeah, you do end up with a lot of folks from Texas and California. But I like that because coming from Cleveland, I then got to meet people from all around the country. I just didn't get to meet more people from Cleveland. So it is a really tough thing to get through. But what's really nice now compared to like the olden days where you have to send manila envelopes back and forth, it's all online and there's checklists. So if you're comfortable with following a checklist, getting things done on time, this application process keeps getting easier. So yes, academically competitive. We do look for people that can perform high. I'll talk about what happens to folks that apply that maybe aren't hitting these numbers. But what we do is we'll tell you, hey, last year here was things like the average GPA and the standard scores. So not every year are you going to see like a minimum score you must hit, but we will tell you things like the median, the means, and the ultimate strategy is while you're in high school, you should be learning and pushing yourself no matter where you're going. But if you're going to use any of these numbers for reference, be on the high end, right? If the Air Force Academy ever tells you an average number, and this can sound really cocky, but be above average. Like if that's don't put yourself as like the target like is to be average. The goal is to be above average in every statistic that you're going to see with applying. Now, if you don't hit it, because we're not talking minimums here, it's okay, but we do things like super score. So on the ACT, you can go back and try again. And if you guys aren't familiar with super scoring, we'll take like your best English out of 4 tries and your best math, reading, and science out of X number of tries. And that's what the Air Force Academy will see. Does that make sense? And yeah, class ranking, I know, especially out here, we can have like really small schools. So percentages can get a bit skewed, but we are looking for folks that can put themselves at the top of the class. Now, again, my advice, how you put yourself at the top of class is not by taking the easiest possible classes and just getting A's. It is instead pushing yourself where ideally, if your school offers it, by your senior year, you're almost for sure lined up to be in a lot of AP classes, and you're setting yourself up to take the AP test well. And if not, like if you're in Baraboo, you should be trying to then like scoot yourself to the point where you are maybe going to the UW satellite schools for college courses. But you do want to push yourself pretty hard. Questions on this part?
Like, for example, what were your scores? Do you remember your scores from your ACT?
I think my ACT average was like 30, but I did take it a couple of times. So that was through super scoring. Yeah. And then SAT, I think, I don't even know if my numbers compared to your numbers now, but like I think the test is what you use. Yeah.
So can you explain super scoring first?
Oh yeah. So let's say you got you took the ACT and you did really well in English, reading, and science, but your math stunk. So if you're looking at these numbers, let's say that you maxed, 35, 33, 34, but at 27. You signed up for the ACT, you took it again, and this time your math was 32. What the Air Force Academy will do when evaluating you is take that 32, not the 27. They'll go for the highest of all 4 categories.
All right, thank you.
Yeah, and having a fitness assessment in the application process, your senior year, as you go through, you'll have to take what's called a fitness assessment, where you're doing things like a kneeling basketball throw, which sounds really goofy, especially if you're used to seeing someone usually like a shot throw. But we're really just, I think, trying to sniff out, who's got shoulder injuries that they're trying to hide and mess in the application process. And then doing things like pull-ups, which I remember when I started training to go to the Air Force Academy, I could do this many pull-ups. But through a lot of practice over my junior year and then going into my senior year, I was able to get that number up to 9. And then while at the Air Force Academy, got up to like 21 because again, fitness is a huge part of the culture. Doing things like a shuttle run, imagine the NFL Pro Agility test. We're looking to make sure that people can move quickly, crunches, push-ups, and then a mile run. So as a person that helps people get through the application process, it's usually not a good idea to schedule a 1 mile run in February in Wisconsin, unless you have access to an indoor track. So as you start thinking, especially for the juniors, you may want to think about doing like your candidate fitness assessment more like in the early fall when you can come off of a summer of training. And I think I'd already mentioned this. We're looking for folks that have leadership potential, not just folks that have like really big, shiny resumes. So if you have access to joining any of these programs, I recommend that you do. Now, I've worked with folks that have also then like gone in on programs that aren't listed here. I helped one applicant who went all in on their high school's robotics program. I mean, they were a leader of the team. They got their team into like big competitions, and you could clearly tell they were just following their passion, which is, I think, more important than just doing something to get in. But of all these, if I saw an application where you were doing all these things, I kind of get a little bit suspicious, like how well are you doing these programs? So find something that really connects with you, that is focused around leading others, helping others, and then commit yourself to it. I'd like to mention congressional nominations. So I also find time to sit on these panels, and most of these cases for like senators, representatives, you'll have to do an in-person interview with your local congressperson. If after this briefing you're interested in attending the Air Force Academy, I can help you out with these things, but every representative has their own application process, and they're required to post it on their website. So all you have to do is first find out who your congressperson is, and then find out their timelines for their nomination process. Some like to do it in the early fall, some like to wait till Thanksgiving. It can depend. But, yeah, we end up with about 10,000 folks where in the summer, going into their senior year, they reach out to the Air Force Academy and they say, I'm interested, I would like to apply. And then there's an online application you fill out, a pre-candidate questionnaire, and it gives the Academy a sense of like, okay, you're interested, we think you're going to work as a candidate. And then that pool drops down to about 9,000 people, and then they begin their application process. By the time you get to the late fall and the spring of your senior year, we can only offer about this many appointments. So you can see it gets close to about like a 10% acceptance rate if you go from applicants down here. And then at the very end, there are folks, and maybe some of you in here, that could do things like apply to West Point or Annapolis or a civilian university. You know, Embry-Riddle has a great flying program, Purdue, North Dakota State, and you may end up going those routes. And if you're interested in serving, maybe you're going to apply for Air Force ROTC. But that's about how many folks are interested versus what we end up giving an appointment to. Now, if you're in here and you're like, oh, I'm not sure, like if my academics are going to work out well, whereby my senior year I actually meet the standards that he's talking about, we also have a lot of other ways to help prepare people. So in the application process, you could be offered what's called an appointment to the Air Force Academy Preparatory School, and it's an extra year after high school to do things like get extremely good at math, chemistry, and writing, and then also work on things like physical fitness and leadership. And it's another opportunity to apply. I think the worst thing you can do if you're interested in a place like the Air Force Academy, or if you have other goals, is to self-eliminate. That is the guaranteed way that you'll never go where you want to go, is if you just decide, I don't know if I'll make it through the application process. That's not for you to decide. Your decision is to apply and complete. So there's a lot of folks that go to the Air Force Academy, particularly like my roommate when I was there, who it took him 2 tries to get in, and he used the prep school as a chance to sharpen up his skills and then finally get in. We also offer scholarships to other lesser known private military institutions that are all across the country, and it's called the Falcon Foundation Scholarship. And again, it's another year where you go out, you sharpen up your skills, and you can reapply to the academy. I know folks that have taken 3 attempts to get into the Air Force Academy. So at that point, they were already like juniors in college, and they decided like, yep, I'm gonna go. I got my appointment, and they went. But none of these opportunities happen if you choose not to complete an application. So if you're applying to the Air Force Academy, you'll never get a prep school slot if you don't finish the application. You'll never get a Falcon Foundation scholarship if you don't finish the application. So I know some of you maybe have not even started the application. I'll just harp on it. The worst thing you can do for this or anywhere else you want to go in your life is to self-eliminate. It's one of the worst things you can do. Those are my slides to make sure I didn't miss anything. But do you guys have any questions?
I know you kind of talked about some advice, but what's like your biggest piece of advice for like aspiring students or students?
I think the broadest is going to be time management skills and pushing yourself academically. I think those are pretty important skills. What I like, the academy was a absolute trial by fire for time management, because I mean, maybe you all will relate with this, where I had time in high school to hang out with friends or like have a weekend, play Ocarina of Time, or like a video game or something like that, and quickly thrust into this environment, you didn't have any of that time. So I should have learned better time management skills in high school. It would have saved me a lot of nights of being up at 2 in the morning writing a paper that was going to be due in a couple of hours. And then pushing yourself academically. We all probably have had those classes where they're very easy and you can just get 100 and call it good. But those classes don't really exist at the academy. I mean, I remember we had like a 4.0 to 5.0 scale at my high school for honors courses and stuff. So it was like, I was, north of 4.0 my whole high school year. And then I got a 3.1 at the academy my freshman year. And I've never been more proud of getting those grades, because I had to absolutely work my tail off in a way that I've never imagined I could. But in terms of back to your question, it was learning how to push myself really hard academically and not just think like, I got the A, good to go, let's move on. No, it was about actually learning, like, how am I going to learn this material? Again, hundreds of pilot slots, and I'll harp on that just because you all are here as students in aviation, and it pays the way. I mean, I had no college fund set up for me by my parents or anything like that. I knew I had to figure out a way to get to college, and I also knew I had a desire to serve. So when I found this place, which for me, I had to go to a bookstore, buy a book on colleges, and start flipping through. And then as I'm looking at like all the different ones, I find Air Force Academy, and I look at the college size, its programs, and then of course like tuition, it said $0. It's like, what is this? So it was a really cool place, and it's special. But is there any other questions? I could ramble on all day about this, and it's a special place, and I do think the people that I've met that went to the academy from Wisconsin were some of the best people. So I enjoy the idea of trying to continue that tradition. You're welcome to write this down, but my email is dan.var47@gmail.com. We have other admission liaison officers in the state that can help you through the mentorship process. But if you have any questions about applying, let me know. Again, most of the time we're looking at folks to start their application in the spring of their junior year, and then begin the full application process that runs into their senior year. But one other fun story, my brother-in-law, we'll call him a failure to launch. where he was interested in the Air Force Academy and just didn't finish the application process his senior year, right? So self-eliminated. Well, he was in Green Bay and spent his year after high school. Everyone went off to do things. He got to clean toilets for Parks and Rec. And we talked to him, and he clearly was not happy. We got him to reapply to the Air Force Academy, and he's now a C-17 pilot, flying out of Seattle and flying all around the world, living his dream. So I also mentioned this for folks where maybe if you don't get to this application process in your high school career, this continues on as an opportunity. You can be, the oldest you can be is 23 years old by the time you first apply. So you have some time, but of course, most applicants come straight out of high school. But again, that's just a question. That's another example of self-eliminating yourself from an opportunity and then just realizing like you can have a second chance as well. When do you guys start to fly? Or if some of you are already flying?
I'm flying tomorrow.
Oh, cool.
It's probably within the next couple of months. We have to schedule all that stuff out for myself.
What's the coldest temperature you all can fly?
17 degrees.
17 degrees.
It was like 32. It was like right above freezing.
Oh, wow.
Like one time we go to go, it's like minus 32 degrees. The plane performs really well.
Holy
Yeah,
cow.
it was kind of, I actually won a bike.
Yeah,
Yeah, it was pretty cold.
that's amazing. What you all are doing here, I think it's really cool. You're choosing to do this on a Saturday. And yeah, whether I think you want to pursue aviation for your own or in the commercial world or in the military world, I think that's just so neat that this program exists. Awesome. I'm happy to let you all keep rolling. I can hang out a little bit afterwards. You roll back in academic
Actually, we're done right now.
Okay.
Yeah, cool.
Happy to hang out. I'll disconnect and answer any questions you all have. Just let me talk to you guys.
Yeah, I'll say.
Thank you, Marshall.
Of course. Yeah. Appreciate it.
Yeah, we'll be in touch. I'll,
Yes.
If you think this will sustain, I'd love to be part of it annually because this is kind of that sweet spot where for 2 years, they below to get them to start thinking about retaining the question.
We usually do it every year. Every now and then we have 2 sessions, but it's been until I saw my business. This is just like a part-time thing. So, but at some point, well, right now we'll once again we usually start in January. So it runs till maybe like end of April and May.
Yeah.
so you'll have to come over sometime and see her.
We got 2 of them. We've got one we purchased. It's just fine. So it's a big city. So then, because I make a computer myself, I did a lot of work with Expedite and actually created this really nice.
I'll get you over there sometime. You'll just stay out.
You say your email address?
Dan. Dot. Bar. 47.
I missed that part.
At Gmail.
Yep. Dan.bar.